All right, afternoon, everybody. Welcome to I Came to Drop Bombs, auditing the compression algorithm cache?
Algorithm weapons cache.
There we go. Got there. You're currently in South Seas G and H, and we have Cara Marie here for you. Before we get started, I've got a couple notes for you. You can clap whenever I'm done. You can stop by the business hall located in Bayside AB during the day for the welcome reception at 1730 through 1900 tonight. The Black Hat Arsenal is in the Palm Foyer on level 3, and you can join us for the Pony Awards tonight at Mandalay Bay B, C, and D at 1830. If you can get everybody to silence their phones, that's the last thing here, and go ahead and applaud her onto the stage. Thank you.
Thanks. All right, so let's talk about bombs. More specifically, compression algorithms and file formats, and which ones make the best candidates for decompression bombs. So a little bit about me before we start. I work for NCC Group as a pen tester, and there I specialize in web application and mobile security, as well as network security. I am also a Hackbright graduate, for those of you who are familiar with that program. And fun fact, used to be a ticket scalper. All right, so a decompression bomb. What it is a file that's specifically designed to crash whatever program or system is consuming it. So just here, just going to jump right into a demo. We've got a JPEG here that is very tiny. I don't know if you can see it on the screen, but it takes up 103 bytes of space. But the dimensions have been set at 25,500 by 25,500 pixels. So that's actually a very large image, but the headers themselves have been modified. So there's very little image data there. So if I was to open it, it actually crashes preview and my slides. So we go back to that. So that's just a classic example of a decompression bomb. It's not sexy, it's not new, but it can be highly effective against various systems. So you're going to see these most in use with web services, web applications, web browsers, web clients, but also embedded devices can be particularly vulnerable to this type of exploit, mainly because there's a lot of weak hardware supporting it usually. All right, so just a brief history lesson. Decompression bombs have been around since pretty much the onset of the internet. We have been seeing these for quite some time. But unfortunately, I still encounter them on a regular basis with web applications in my testing. And we also see major libraries that deal with data compression being issued CVEs. So libpng, just as one example, was issued as CVE for this exact vulnerability just last year. All right, so I believe the reason for this is that there's a bit of a misconception within the community as to what a decompression bomb actually is. It's more commonly known as a zip bomb, which can be quite misleading because then you think it's only archive file formats. But so this, just to further illustrate it, is a NetSec posting from fall of last year. And what it's highlighting is an image bomb that, when it's fully rendered, is going to take up about 140 gigs of memory. The first comment there is really just, it hits the nail on the head for me. It's a graphical version of a zip bomb. So it also doesn't help that when you Google for decompression bombs, one of the very first results is going to be Wikipedia's entry on it, and that's entitled zip bomb. So it just further fuels the fire as to what type of data compression file format you need to be worried about. All right, another reason why I'm looking into this is there's been a lot of movement within the compression algorithm community, partly due to a little show called Silicon Valley. It's gaining a lot of interest into building better compression algorithms. And so we're seeing a lot of new ones come out, and quite a few of them are starting to gain traction and are being used in our day-to-day web applications and HTTP streams. All right, so this is really just to raise awareness with developers as well as pen testers alike. So that way, when you are building an application or a service that deals with data compression, that you're also implementing the appropriate mitigations to better guard your user base against attacks like this. Well, your user base and you. And then with pen testers, ideally, when you're looking at these applications and services, that you're not going to miss testing for this, simply because it's not an archive file compression data service. All right, so we're going to talk about the three major types But don't walk out of here thinking that these are the only kind that you really need to worry about. They're just the more common ones. So we'll start with the first, the Gzip bomb. So traditionally, this was used by malware authors to knock out antivirus software. So this way they could install their malicious applications on the user's computer without any hindrance. Now with everything being moved to the cloud, this type of attack has much bigger impact. But these types of files, they come in three major, flavors. The first one is going to be your singly compressed file, and that's exactly what it sounds like. Highly compressible content that's been hit with a single round of compression. The second is the self-reproducing compressed files. This type of attack is really a bit contrived in the sense that the user would have to either be completely negligent or just really not paying attention to what's going on their system. But it's still somewhat viable in the sense that, so for example, Safari. The Safari browser does have a feature where it will automatically decompress content that it's deemed safe. And if you were to go to Russ Cox's entry, or rather blog post on self-reproducing programs, he's got a lot of good examples of these. So he's got Zips and Gzip and I think even a tar. But anyway, he's got a lot of good examples that you can download with Safari. And if a user was to do that, then Safari is going to automatically decompress it. If the user walks away or just isn't paying attention, they're going to find that their system is just littered with all these tiny files, and which honestly, that could be quite problematic. The third one is nested compressed files. 42-zip is the most famous example of this. How many of you are familiar with 42-zip? So we've got a few people, that's great. So for those of you who aren't, 42-zip is a 42-byte compressed file that's comprised of 16 compressed files, which in turn have 16 compressed files. This goes on for about 5 layers, the core of which each of them has a 4.3 gigabyte file. So then if this is fully decompressed on the system, it's going to take up over 4.5 petabytes of space, which is going to be pretty effective in knocking quite a few things out. All right, so before I jump into the actual comparison of these utilities, the compression utilities, I want to talk a little bit about the ratio that I used for the comparison. So in the real world, when you are looking at compression algorithms, you're going to be concerned with really 3 things. First is obviously the level of compression that you can gain with that utility. Second is the speed at which you can gain that level of compression. That's pretty important usually. And then the fourth is how does it handle real world data? So content that really isn't highly compressible. Since we're looking at this from a malicious standpoint, we don't care about speed because no attacker is really going to care if one utility is faster than the other. They're just going to be concerned about the level of compression that they can achieve. And again, we don't care about real world data. We only care about highly compressible content. So at least in the comparison for these archive compression utilities, we're taking a look at, or we're using a zero-generated 10 gigabyte file. So it's going to be very compressible, highly compressible. And we just want to see what the difference is between the uncompressed versus the compressed. So there's only the one that we're worried about. All right, so just to when I look at numbers on a page, sometimes it doesn't always just jump out at me what the big impact is. So we've got a visual representation here of the utilities. And as you can see, bzip2 is really just king. Even Czar's implementation of bzip2 is just, it's absolutely massive, the compression level that you can achieve using those utilities. It's so much so that you can't really tell how the other utilities measure up against each other because they're pretty much just flatlining. So if we remove that from the picture, then we can get at least a better idea of how they all measure up. And 7Z and XZ are definitely the big winners here, with LZ4 coming in last. And the reason for that is LZ4 is just very, very fast. So you sacrifice a lot of the level of compression as a result. All right, so just getting further into the details. So we've got our utilities, sizes, compression ratios, but I've also thrown in the algorithm that each of these utilities is implementing. Now, the reason why I did that is because I wanted to highlight the fact that simply because you have utilities that are implementing the same algorithm, and you've got actually 2 examples up there. So we've got bzip2 and Czar. Czar's implementation of bzip2, but then we also have 7Z and the rest of the utilities that are implementing deflate. As you can see, that there is a significant difference when it comes to the deflate implementation. 7Z's Gzip implementation is just light years ahead of the other utilities. And there's a small difference between bzip2 and Czar's implementation. But it just really highlights the fact that simply because they're both implementing the same algorithm, that does not make them equal. All right, so Security 101, just mitigating decompression bombs in general. It doesn't matter really what kind of data compression type you're dealing with. You're going to always want to limit the amount of resources that you're making available to the processes and their children. You never want to just give them the lay of the land and suck up all of those resources. So in Linux, you can do that with C groups, but you can also programmatically do that with various languages, and we've got a Python example up there, just a little snippet there. In addition to that, more specific to archive bombs, you always want to restrict the output file size, put a sane limit, a maximum limit on the actual output file size that you're going to allow. And you're also going to want to take it one step further to ensure that if there are multiple files within, that they don't exceed that limit as well. So you definitely always want to watch out for that. All right, so next up, we've got the image bombs. And these are honestly my favorite, mainly because in testing, this is probably the most common use case that I deal with on a regular basis. And they can be highly effective in DOSing web servers, as well as web clients, mobile clients, and desktop clients, as you just saw. So here, we're taking a look at just a few various more commonly used file formats. And JPEG 2000 is really just king. It's so amazing, the compression that you can achieve using that file format. And it really is unfortunate that it's not more commonly supported. So taking a look at the ones that are more universally supported, at least online, you've got Zopfly PNG, which is really just knocking everyone else out of the water. And for those of you who aren't familiar with Zopfly, and I'm sorry if I'm butchering it and not pronouncing it correctly, if there's anyone here that works on that, but Zopfly PNG is a newer Google algorithm that actually takes a look at PNGs and is able to achieve better compression with those file formats. But it doesn't mangle it to the sense that it's a completely new format. It's still, those images can still be parsed by regular PNG parsers. So that's the king right there. But I also want to caution you not to discount PNG, which is obviously third place here and second to last in the whole scheme of things, mainly because at least in my testing and a lot of my colleagues' testing, it's usually PNG bombs that you're using to effectively cause denial of service with these web servers. So it's just something to be aware of. It's not a benign threat. All right, so, and then just a note on what we used here. So I used a 10,000 by 10,000 pixel image to calculate these ratios. Granted, that's only going to take, that's less than 100 megabytes of memory. So that's not really that serious or really interesting. But if you were to multiply that to really just, what, 30,000, 40,000, it's going to take up a significant amount more of memory and really just knock it out. So as a result, you always want to put sane limits on the image dimensions that you're allowing, and you always want to check the image dimensions prior to processing. And you can do this, various file formats have headers that actually state what those are, and you can usually rely on that unless you have someone being super evil. But with libpng, just as an example, with the libraries that you're using to process the images, you always want to modify the default configurations, because most of the time those are set for user ease, not necessarily security. So just as an example, libpng has the default setting is 1 million by 1 million pixels. And unless you're NASA, you don't really need to deal with an image that is that large. So you definitely want to run in and modify that. This isn't a silver bullet, though, checking the image dimensions, because as you saw in the demo there, I had changed the headers to reflect an extremely large value that obviously wasn't the case, and it caused preview to crash. So this is more of, this should always be backed up by the limiting of the resources that you're making available to the process, to processes. And you also want to ensure that you are failing gracefully, that you're not going to have a crash like we just saw. So with web servers especially, you always want to use separate workers that are going to be performing these intensive tasks on the images. So if you're allowing the users to modify the size or performing other modifications to the image, you always want to use a separate process to that. And again, the reason for that is if you have an attacker uploading just a massive image, or even just a naive user doing so, that's going to knock out that worker, but not the server or process that's hosting your service. And so then your user base is going to be adequately protected. You'll just have one single user who's not very happy, which in the grand scheme of things, that's fine. Another cautionary, just when dealing with image file formats, they're a lot of fun. There's a lot of different things that you can put into these file formats to get remote code execution, image-based cross-site scripting. Like, there's a lot of different types of attacks that you can perform with images. So just as it's further guard against that, you always want to ensure that you're only accepting the minimum of that you absolutely need to perform whatever process or function that you've built in. All right, so moving on, we can jump into HTTP bombs, and I actually have a more in-depth demo for you. All right, so we've got the Firefox browser here, which has successfully requested and loaded a zero-generated 10 gigabyte HTML file that is not Brotli encoded, because it says it's not Brotli encoded right there. You're just gonna have to take my word for it. And for those of you who aren't familiar with Brotli, it's a newer compression algorithm that's been developed by Google and is now supported by both Firefox and Chrome. I think in the very near future, we're going to see it in a lot of other modern browsers because I'm already encountering it in testing web applications. So it's gaining a lot of traction. But as we can see, Firefox has been able to successfully request Brotli encoded data. I don't know if you can tell, but that content encoding header does have a value of BR. So if we try to request the same 10 gigabyte file, but this time it has been compressed with Brotli, it crashes. So Firefox can't handle that. And it crashes the entire application. So whatever other sites that you're taking a look at, the user is now going to have to restart everything, which can be quite annoying. Obviously, this is just a single target. Like, it doesn't have that big of an impact, and it's more of an annoyance for the user. But this can be a highly effective attack if it's the client that's sending this request to the server. So these HTTP bombs can be used obviously for web servers, web clients, but also any embedded devices. In the Internet of Things, we've got a lot of things that are being put online, and so these bombs could be used to target those as well. All right, so just taking a look, Gzip, again, not a big surprise, but Gzip performs the best out of all of them. But Brotli is doing pretty well. It's holding its own. And so taking a look at this chart, just a note that I've got the delimiter there just to designate the differences between the algorithms in the sense that the top portion are HTTP compression that is universally supported. The bottom ones are not supported universally, but I think Brotli is very quickly going to be moved up to the top. And then obviously it would take the cake. And again, we've got Gzip Bloat, which is another Google algorithm, but takes a look at Gzip and gets better compression when it comes to real world data. But as you can see, when it comes to highly compressible content, not so much. Gzip still is the winner right there. All right, so again, limiting resources, and there's various directives that you can do so for that. But you're also going to want to limit the request sizes that you're accepting. And obviously, because you don't want an attacker or really your users to be sending you the world, you want to definitely limit the request. That way it's to a sane size and not going to knock you out. But in addition to that, you need to limit or place a maximum on the compression ratio that you're going to accept. Because even if the request size is within those limitations, obviously they could have just upped the ratio itself. And so they're still sending you the world and killing you. So those are the three major types. You've got HTTP bombs, you've got image bombs, and then you also have the zip bombs. But there's a lot of different services and applications that deal with data compression. And so there's a lot of different, at least potential for this type of attack to be effective. So you've got version control systems. I actually, in performing this research, I inadvertently added a uncompressed 10 gigabyte file to the repo that I was using for this. And I ended up knocking out our internal Git repository for an entire day. So that was fun. So even version control systems can be vulnerable to this if you don't have the proper mitigations put into place. All right, so in testing. So after you've built your application and service and you've properly mitigated and you think that you've got the configurations right, you always want to test to ensure that that is true. And so we've got 3 tools. The 2 were not written by me, but the last one was. We've got 3 tools that can be used to test various use cases, just depending on the context of how you're using the compression. So the first is Gzip Bloat, and this can be highly effective in testing to ensure that your servers or web clients are appropriately handling these just ridiculously massive bombs. In addition to that, you've got the burp image extension. And what that is a lot of the web applications are now implementing, or rather allowing users to modify image sizes using request parameters. And that is a potential vector for denial of service as well. So this extension will alert the pen tester to that, and then you can ensure that they've got the proper mitigations put into place to prevent a DOS. All right, and then finally, I've got bomb.codes. It is live now. I have a pretty big update that I need to push, that I will be pushing later on today. But what this really is during this research, I've built a lot of bombs just to test various applications and things. And I've found them to be personally quite useful. So I'm opening it up to the world so you can go and with a click of a button download some pretty large bombs that would normally take quite some time to actually build, and hopefully it's a time saver. And these can be used in a lot of different, since they are single use and it's not really a tool that's just directed at HTTP bombs or just directed at images. You can use this with anything and everything that obviously accepts a file. So it's just a bit more versatile. So in summary, when you are mitigating for decompression bombs, you want to ensure that you've got all of these different mitigations working together. No single one is going to be a silver bullet that's going to adequately protect your user base. And then also, and I cannot stress this enough, you always want to perform dynamic testing on your application. Never relied on you've implemented the mitigations properly in the code, or that the server's been configured correctly, because maybe there's an edge case that you missed. So dynamic testing is definitely where you want to go with that. All right, and so that's all that I have for you today. Thank you. Okay, good deal. 3 minutes? Well, if you guys want to talk bombs or anything else, we can do that too. And you're talking for HTTP compression, or you're just talking when an application accepts files?
Well, I'm thinking that server will be attacked by HTTP compression.
Okay.
And then Buffalo or something.
Right.
Yeah. And I guess the question is, where's the payload go?
Oh, I see. Yes, if it's in a post, then you would definitely put in the body. You just send a very large amount there. So that's where the payload would go in that respect. But yeah, most of the time with servers, though, you don't, unless obviously you're having your users send you very large files, you don't normally want to enable or allow requests to be compressed in that respect, just because you're opening it up for this type of attack. But obviously, if it's a business requirement, then you're going to have to. Mm-hmm. Definitely. Yeah, and even with file upload features, if you are accepting files, you don't want to accept just the whole world. You want to definitely limit it to a specific set, because that'll make it a lot easier to control and a lot easier to guard yourself against it, that type of attack. Yes? That's actually on my list of things to do, but no, not yet. But yeah, I've got a massive list that I'm working through, and that's one of the next ones on the list. Yes?
It's like the highest method ratio you've seen for like a valid file that isn't just somebody compressing all of your
For a valid file, so you mean like with real world data?
Yeah, like, how do you differentiate real world data from a confession bomb?
Yeah, that's going to be a little bit more difficult in the sense that you'd want to compare the actual size of the compressed output with the uncompressed size. Like, so Zip has a header that does let you see what the uncompressed size of that content is. And so if, because I haven't really looked at real world data, but that would be interesting. You would need to see what the percentage is, then the difference there, and just testing, I guess. But yeah, that's an interesting idea too.
So you're thinking like maybe if inspect Zip, like I've got a gateway that's kind of email attachments.
Right.
So I could write, I see a zip file coming in with attachment, I'm already suspicious. But with a small zip file, I know it's a flat screen. It's okay to zip out the main zips, that used to be okay. It's hard for people to do that. But if it's sort of 1:1 ratio or something, that would be a zip file.
It could be, yes. But I wouldn't just rely on that though, because you can hide them. Like you can get pretty clever with the content that you put in there. So just like looking at the size and the ratio itself isn't going to be, a good the solid way to ensure that it's a bomb versus real world content.
Well, child process resource limits, it's usually bombs.
Yeah, like if you absolutely need to test it. But yes, if it does have an extremely high compression ratio, then likely, yeah, it's a bomb. Yeah, that's true. And that's one of the reasons why you need to have all the other mitigations put into place for this type of attack, because, you can lie.
So you mentioned the things that you talked about are doing resource exhaustion type of attacks for files that are still ostensibly within the specification of the compression algorithm. Have you done any work with things that are malformed within the compression algorithm triggering other types of vulnerabilities?
No, I have not. This guy has. Oh. Wait, I'm sorry, say that again?
You could create a stream log, like these did, you could restart compression. And so you could do that without case where you start with wait times.
Yes, definitely. That would be a good idea. So do we still have time for one more question? Okay, if there's, oh, yes, sorry.
I have a question. Have you looked at all the like Delta and doing compression stuff or like video or anything like that? Because you can do in that sort of space and streaming media.
I am starting to explore it, but I don't have anything really good yet. I'm hoping for something, obviously just because it's fun for me, but yeah. I will be, that site, bomb.codes, if I do find anything interesting, that's where I will be posting and updating. All right, thank you guys so much.